Block reference table. So what's the general idea? So general idea behind this feature is ability to reference one data block from two separate files. So a lot of people actually, when they hear that ZFS is copy on write, they wonder why this feature is not already implemented. It must be so easy. You can think of this feature as a let's say file cloning. So you have a file, you want to clone the file, and basically both copies of the file are now have this copy on write property. So if you modify one file, it doesn't modify the other file. So it's not a hard link, right, where you have two separate file names, but this is basically the same file, same data. You modify one file, the other one is also updated because it's actually exactly the same file. It's referenced by two different file names. So this is different. Two separate files, they have their own properties, their own permission, ownership, etc., but can share data blocks. It turns out that Linux already has this feature through with ButterFS. There is a special ioctl, and there is an option for CP called reflink that you can use to clone a file. And there is a dedicated system call on macOS, clone file, which also allows to do exactly the same thing. So what are like general benefits of feature like that? So definitely the main benefit is space savings when cloning files. If you have large files, you just want to modify them slightly, you can just copy the file, and it takes no additional space. Another huge benefit is when you try to recover a file from a snapshot. So you accidentally deleted a file and you want to bring the file back. So now if you just copy the file back, it will consume additional space because the data blocks will be copied. It will allocate additional space for all those data blocks. So some people complain about this. So it would be nice to be able to not to pay the cost to just recover files from a snapshot. Also, such a copy will be super fast. So if you clone a file, we don't read data blocks. We just read the parent blocks. We just need block pointers that will clone. So we read and write only a fraction of what is read and written when you do regular copy. So it should be extremely fast. And another benefit is that you can move files between data sets. This has some limitations. I will mention about them a bit later. And some may think, why do we need this if we already have the duplication? It serves pretty much the same purpose. And you can think about this block reference table as a manual dedupe that you decide what you deduplicate. But with block reference table, there is no cost on write. With the duplication, you have to look up, you have to go through dedupe table. So when you write and you have large dedupe table, there's a lot of problems with that. If it doesn't fit in RAM, you have all those performance problems. So can be quicker, it can be slower. With block reference table, if you do a regular write, we don't touch block reference table. So there is no additional cost at all. If you do, of course, file cloning, there is a cost on write, but it's much smaller. As I mentioned, the copying it will be super fast. And it works with any checksum algorithm. You don't need cryptographically strong checksum in order to be able to use block reference table, because we don't care about the checksum itself. And another benefit is that with dedupe table, and because we use cryptographically strong checksum, the blocks are scattered throughout the entire dedupe table. So if you have one file, few blocks, you may end up reading from totally different places in dedupe table. With block reference table, there is a high chance that all the entries that you need are very close to each other. So as I mentioned, dedupe tables can grow very big. Dedupe table entry is pretty large. This is in-memory size of dedupe entry. So it's almost 400 bytes. It's 1/5 of this for block reference table, which also means that you can fit much bigger block reference table in RAM. So with dedupe, the big difference is that in dedupe table, you have a lot of entries, most likely, that have only a single reference. This is not possible with block reference table. There are no entries with a single reference. If there are a single reference, we basically just remove the entry from block reference table. So the table only contains the reference that are actually meaningful, that actually reference blocks that are referenced more than once. And as I mentioned already, dedupe table, all the blocks can be scattered throughout the dedupe table. So other costs and no costs. So as I mentioned, there are no penalty for regular writes. There is no penalty also for regular reads, of course. So, but this is similar to dedupe. If you don't use this feature, there is no cost. So simply, if you're afraid that block reference table can also grow big and there can also be performance problem, you just doesn't have to use this file cloning facility, and basically it will just work. There is a cost when you free a block. So on every free, we have to consult block reference table. That's the difference between this feature and dedupe. With dedupe, we have a special flag in block pointer, the D flag, that says that this block is in dedupe table. So if there is no D flag, we simply don't consult the dedupe table. With block reference table, there is no special flag in block pointer. The reason being that we want to clone existing blocks. So when we wrote the block, we simply didn't know if this block is going to be cloned or not. So there is no special flag, and of course we cannot modify block pointer. So simply on every free, we have to go and check if this block is referenced in block reference table, and if it is, we have to decrease the counter. If it's not, then we did some extra work. But as I said before, if you don't use it, there is no cost, because the table will be empty, so you don't have to worry about that. And when you just want to use this feature to move files between data sets, let's say, the table won't grow because it will grow only for a short while when we put the reference into the table. But when you remove the original copy, we will remove the entries from the table. So the cost is only well, the table will grow only for a very short amount of time. So when it comes to design, as I mentioned, there is no BP rewrite, so we cannot modify BP. So we cannot either put a special flag or we cannot put a reference counter into a block pointer. That would be, of course, like obvious idea to just increase some counter within block pointer, but block pointers cannot be just modified, so we need additional table. When we clone, we don't read data blocks. It must be super fast. Just the parent blocks, just the block pointers. We just add reference to the table. And I hope that this feature can be always on. So I would prefer not to have a special property just for that, because as I mentioned, if you don't use this feature, there is no additional cost. And block reference table entry is extremely simple. It's just we just need to say which VDEF and the offset of the block, and of course reference counter, but the entry itself is extremely small. There are some limitations that it's worth mentioning. Blocks that are cloned, this information cannot be sent over. So we cannot preserve this information when we do ZFS send. This might be a bit, let's say, discouraging, but the same with, there is similar limitation with dedupe, but because of the checksum, dedupe can reconstruct the, basically when we send and receive the block, dedupe can figure out based on the checksum that this block have more entries and simply update dedupe table. Here we have no idea if the entry is on the target system, and the target system has no idea if the data that is coming have more references. So if you use block reference table a lot and you will send data set like that over, unfortunately, it will be much bigger than the original data set. So that's a bit disappointing in my opinion. I would like this to work across data sets. I would like to be able to move or clone files between data sets. But of course, I don't want this to work when there are different encryption keys. So this is similar limitation to dedupe. If the encryption key is inherited, like through ZFS clone, then that should be fine. But if it's totally independent encryption key, then we won't be able to clone files between data sets with different keys. And of course, between a data set that it's not encrypted and dataset that it's encrypted, and the opposite. I would like this still to work between datasets with different compression algorithms, because you still don't pay the additional price. So even if you clone a file to a dataset with compression off, a compressed block to dataset with compression off, or the other way, I would like this to simply work, because when you start to override the blocks, we will simply use the algorithm configured on the specific dataset. Okay, I was trying to be brief, but it really went quickly. So I guess there will be some more time for questions, but I will just mention status of the project. So I don't want to put your hopes too high. This is just my hobby project, so the progress is very slow. I was able to hack some very early prototype. I'm using additional system call, but I'm not yet sure if this is best idea. On FreeBSD, you can register additional system calls from kernel modules. I'm not sure about Linux, probably too, although ButterFS is using additional ioctl. So maybe this is a better way to go. But for now, I'm just using additional system call. I am able to read block pointers to some extent. I can update the table on write. There is some things that already work, but I'm sure there are a lot of corner cases we have to consider that are not considered at this point at all. So it's a very early prototype. So if there are any questions, I'm happy to answer them.
It looks like there's a few questions. If you click the Q&A, do you want to read them, or do you want me to read them to you?
Okay, sure. 1 sec. So
you can probably stop screen sharing, and then you'll see the in the Zoom there's a Q&A with there's 4 questions queued there.
So a question from Crest first. Could this be used to implement rebasable tin jails? Okay. Definitely you could, because I think that the story behind that is that if you would like to implement jails on top of ZFS, a common practice is to use ZFS cloning. So with ZFS clone, you have initial free copy of your base system, but when you update the jail, you simply have to override the files, and you start to lose all the savings, because ZFS clone only gives you the initial savings. So I think yes, definitely. If you will just install the updated system files from some template, and you will use file cloning for that, and not just regular copy or install tools, which of course we can extend copy, CP, and install to use file cloning if feasible. So then yes, definitely, and you can keep the savings even after updating your jails. I hope that's answered the question. So Christian is asking, what is the reason why the BRT files not be sendable? So the problem here is that when we send the file, we don't really transfer any information about block pointer. Matt can correct me if I'm wrong here, but at the DMU level, we lose that information. So we simply just send data blocks, but at the destination ZFS, they will have totally different block pointers. So there is different VDEF, different offset, and this is what we use to reference the blocks. So we lose that information when we send. It's totally different on the destination data set. So so simply, and especially that I would like this to use across data sets. But even within a single data set, we cannot assume that there is a copy of the block already, because ZFS send and receive is one directional. So we discussed that initially. If anyone has ideas how to address that, I'm happy to discuss that. But at this point, I think that's unfortunately a limitation of this feature.
Just to clarify, there may be some confusion about whether the files, are you allowed to ZFS send something that has BRT stuff in it?
Okay, okay, so yes, definitely, because when you read the file, or when you read, you simply don't touch BRT. So this is just regular files, and so yeah.
Yeah, so you can send it. It's just that the block sharing of BRT doesn't come across with the ZFS send. Is that correct?
Yes, although that's an interesting question. If I clone a block that it's much older, it will be included in a specific snapshot range on the destination data set. So
maybe you could detect that.
Yeah.
But in any case, the discussion is really about could we preserve the block sharing of BRT, not about whether send is going to work at all with this.
Yeah, so preservation, I think it's not possible, but
cool, thanks.
Okay, question from Johnny. Why do we need another table? Can't we simply use dedupe tables? So I was initially I was thinking about that, but I believe that additional table is a better option because it's much lighter. So the entries are much smaller because there is no checksum. It's simply VDEF, offset, and counter. And also dedupe table is a bit different. Like I mentioned, we put every single block into dedupe table, even blocks with a single reference. So with BRT, there are no such block with single reference. So if the block reference count drops to 1, it's removed from the table. So there are different dynamics. It's also different way to clone files because we have to do a special read because we don't want to read the data, and we have to do special write because with dedupe you actually write the data itself, and then within the ZIO pipeline you decide that after calculating the checksum, you decide if this entry should go to well, you decide earlier because the dedupe property is set on the data set, but basically you have to provide the data and that should go through ZIO pipeline, so you can calculate the checksum and either put the block into the dedupe table or just write the block to the disk. With BRT, we don't want this last step. There are no ZIOs with the data itself. We finish at the block pointers, and we have no data.
Yeah, I think a big reason that you wouldn't want to combine it with the dedupe table is in case you're also using dedupe. You don't want to, like when you're doing a free, whenever you're doing a free, you have to look in the block reference table. You don't want that block reference table to be larger than necessary. So you don't want to be, you wouldn't want to have to go look in the dedupe table when you're doing a free that doesn't involve dedupe, but might involve the block reference table.
Yeah. So my hope is that BRT will be much, much smaller. Of course, you can always go to extremes, but there is, you need to make much more work to actually make BRT a performance problem, because as I said, it's much more compact and specialized. Okay, question from Crest. Could this accelerate copy file range for the NFF server? To be honest, I'm not familiar with the system call, so I'm not sure how it works exactly. So maybe somebody else know how it works.
I think that it would be able to take advantage of this. It's basically like copying a range of a file to another file.
So that's interesting, because there are two approaches I'm considering. So one is a clone file system call that basically clones entire file, but this can also be implemented as cloning individual blocks. Then you could punch a block in the middle of a file that is basically a clone block, but of course you have to preserve like alignment. So you cannot punch the block anywhere into the file. It has to be at the block size boundaries. So it's a bit limited. So if a copy file range allows to move the data into any place within a file, then it won't work for general case, but it can work for some specific cases where you preserve the boundaries.
We're running a little bit short on time, so I'm just trying to answer some of the questions in text as you're typing. But we probably have time for like one or two more if you want to answer them live.
So question from Alan. What type of data structure does the BRT use? Is it stored at the top level of the pool? Yes, it's basically, I simply try to reuse as much dedupe code as possible, or at least use it for more like an inspiration, but it's very similar to dedupe in that regard. So it used the same data structure, similar data structures in place in the same exact place in the pool. So there's a lot of code that is reused from dedupe. Okay, and question from Tenzin. If the source snapshot removed, what happens to the copied cloned file? Does the file get copied up to the live system? That's a very good question, and to be honest, I didn't figure out yet the interaction between BRT and snapshots. There are some potential questions how this fits into intuition of the user, how the block is the life cycle of the block, because as I block pointer is not updated. So this is something I still need to investigate. Okay. So last question from Christian. You could have the zero hint whether it used the BRT or not. So yes, we do send this information through Zio pipeline that we are using BRT, and there is no data, and it has to be it has to just update BRT table. So yes, it handled in a special way.
Cool. Well, thanks everyone who thanks Pawel for telling us about this. This is a really cool idea, and thanks to everyone who asked all those great questions.